Hello everybody, and welcome to our final video for this unit. Today, what we're going to be discussing are pedigrees. Now, pedigrees are kind of like family charts, so by the time this is all said and done, you should know what a pedigree is, what symbols are involved, and how to interpret the information on a pedigree chart. From this, you can even go ahead and help figure out genotypes and phenotypes of individuals. So, let's get started. So like we said, a pedigree chart is very similar to a family tree. So this shows genetic connections among individuals. So mothers, fathers, daughters, sons, granddaughters, grandsons, and so on and so forth. It also has standardized symbols that are universally used. So even if you go ahead and show this to somebody that doesn't speak English, they should still know the symbols. And this may be used to estimate probability and patterns of inheritance over generations. So it'll show us what possibilities of future generations may be. So as we said, there are basic symbols of a pedigree. Squares always represent males, whereas circles represent females. If the individual's box is filled in, so for example, if we have a square that's shaded in, that shows that the individual that square represents had whatever trait we're looking at, be it a disorder, a certain trait, what have you. Same thing with the females. If the circle is filled in, they have that trait. Now, when going ahead and building a pedigree chart, what you may see is something like this. So here, there is a vertical line leading from the two. So if we have a line connecting two individuals like we do here, this shows mating. And here, if there's a line coming down, that shows an offspring. In this case, we're looking at one son being born. The final thing we have to consider is if the individual's box or circle is shaded in halfway. If only half of it is shaded in, like we have down here, that denotes a carrier male. So they won't show the trait, but they could pass it on. And same thing for the females. Using these symbols, that'll go ahead and give you exactly what you need to build a pedigree. Now, go looking at the different methods of transmission, or how traits are passed on through generations. By looking at the pedigree chart, we can actually figure out which way these traits are passed. So in this case, if you go ahead and take a look, the males, represented by the squares, either have the trait or they don't. Meanwhile, females either do not have the trait or they are carriers. So in this case, if we're looking at individuals where males have it or they don't, and females can be carriers, we call this sex-linked recessive. So from here, we could go ahead and actually figure out the genotype of each individual. So we would have XY, XX, XY, XX, XY, 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 and XY. Now, if they have the disorder, that means they must have at least whatever this is on one of the X chromosomes. So here for the males, these two would have it on their X chromosomes. And here for the female, since she's a carrier, that would show up only on one. So the key for this is look for a male pattern and female carriers. In our next example, you can see that this trait affects both males and females evenly. So we have one female that has it, and we have 3 males that have it. So they either have it or they don't. Here, we would call this autosomal dominant. So in this case, if we have generation 1, generation 2, and generation 3, the trait shows up in all 3 generations. Now, once again, just like before, we can figure out the genotype of each of these. So in this case, considering this is a dominant trait, this should most likely be capital A, lowercase a. Since these individuals don't have it, anybody that doesn't would be recessive. And these individuals here would also have to be heterozygous. That's a terrible A. So let's check the next trait. Here, we have 1 in the first generation that has it. We have none in the second, none in the third, but 2 in the fourth. So in this case, what we'll be looking at is autosomal recessive. So it skips generations, but keep in mind that isn't always going to happen. So in this case, if this is a recessive trait, remember the only way you could have the recessive disorder is with two little a's, or two lowercase letters. So these individuals that have the disorder would all have to be denoted by lowercase a, lowercase a. Finally, let's go ahead and build our own pedigree chart. Oh boy, this is going to be fun to say. Debbie married David and had 3 children, Darren, Don, and Derek. David, Darren, and Derek discovered they have muscular dystrophy. Derek married Dee Dee and had 2 children, Denise and Destiny. Denise also has muscular dystrophy and married Dirk. They had 2 children, Dee and Devin. Dee also has muscular dystrophy. So, if we start off at the beginning with Debbie and David, that would be our first generation. Their children, Darren, Don, and Derek, would be our second generation. Their children would be our third. And then their children of that cross would be our fourth. So, let's go ahead and listen to what they had to say. So what we have here, Debbie married David and had 3 children, Darren, Don, and Derek. David, Darren, and Derek had muscular dystrophy. So any individuals that have muscular dystrophy is the trait we're looking at here. So in this case, we would go ahead and fill the boxes or circles in. So Derek married Dee Dee and had 2 kids, Denise and Destiny. Denise also had muscular dystrophy. So we have to go ahead and shade in Denise's box. Now she married Dirk, and they had 2 kids, Dee and Devin. Dee also has muscular dystrophy, so we would have to fill in her circle as well. So what this should end up looking like is this. Now from here, what we can do is go ahead and figure out the genotype and phenotype of each family member. So remember, if they're filled in, they have the disorder. And if you take a look in generation 1, 2, 3, and 4, there is 1 individual in each, meaning that this trait must be passed on via autosomal dominance. Now this means that the dominant trait is going to be muscular dystrophy. Meanwhile, the recessive trait will be healthy. Now the easiest way to do this is let's look at all the healthy individuals. So considering healthy is recessive, that means that any individual that does not have a marking by them must be recessive. There we go. Meanwhile, any individual that has the disorder must have at least 1 capital letter in their genotype. So let's go through and mark that. Now in this case, we're making each one heterozygous because if you look at the offspring of the crosses, there are recessive individuals. If it was a homozygous dominant trait, capital A, that means that all the offspring would have had to have that trait, and they don't. So let's see how we did. Yep, seems to be that is an autosomal dominant trait. And it looks like we went ahead and got the genotypes of each individual correct as well. I mean, granted, we used A instead of M, but you get the point. Now, there will be some more opportunities for practice for this as we progress today. So if you have any questions, please make sure to go ahead and contact your instructor. They'll make sure to go ahead and put you on the right path. And until the next time we meet, y'all go ahead and take care of yourselves and have a wonderful day. I'll see you in the next video.